Hi, welcome to this video session on conversion of gray code to its equivalent binary value. Supposing we are given a gray code which is 101101. This is a number. We want to convert this into its equivalent binary value. Now, before we start this, we'll again keep our XOR truth table in front. If A and B are the inputs, and we know that A XOR B, in this case, since both A and B are 0, the output will be 0. A 0, B 1, XOR value is 1. When A is 1, B is 0, the XOR value is 1. And again, when A and B both are identical, then output is 0. So from this truth table, we can observe that when A and B are same, then the output is 0. And when A and B are different values, the output is 1. Now we'll use this to find the equivalent binary value. So here is the gray code that is given to us. We write the bits 101 101. Now the first step in finding the binary is we will copy down the bit 1, that is the most significant bit of our gray code. So this is the most significant bit of our gray code. We will copy this bit into the most significant bit of the binary value. So this is the MSB of the equivalent binary number, and this bit will be simply copied down. Now from here onwards, how do we calculate these bit values? So we will take each value that we have obtained here. So we will take this value and we'll XOR it with the next bit of the gray code. So 1, we'll XOR it with 0. So that will give us 1. So this is the XOR operation that we are seeing here. 1 XOR 0 is 1. Again, this 1 XOR with 1, that will give us 0, because we saw that when both the bits in an XOR operation are identical, then the output is 0. Again, 0 XOR with 1 will give us 1. This one XOR with 0 will give us 1. And here 1 XORed with 1, since both bits are identical, this will give us 0. And therefore, we can say that 1 0 1 1 0 1, this is of the gray code. So let us just write this subscript as GC, gray code. This is equivalent to 1 1 0 1 1 0 1 1 0 1 1 0. This is of the equivalent binary value. Now in this second example, let us take the conversion of 010101 into its equivalent binary value. So here we have again the gray code, the bits that are given to us 010101. This is our most significant bit. And how do we get this binary value? Let us observe. So the most significant bit of the gray code becomes the most significant bit of the binary. So this value is simply copied into the MSB of the binary. But thereafter 0 XOR 1, we will XOR this 0 with 1, that gives us 1. And then again 1 XORed with 0 gives us 1. This one XORed with 1 of the gray code, this gives us 0. 0 XORed with 0 is again giving us 0, because both bits are identical. So from our truth table, we know when both bits are identical, the output is 0. And here we have 0 XORed with 1, that gives us 1. And therefore we can say that 0 1 0 1 0 1 of the gray code is equivalent to 0 1 1 0 0 1 of the binary. So this is how we convert a gray code into its equivalent binary value. In this third example, let us see how we convert a gray code into the decimal number. Now, This will involve two steps. In step 1, we will first convert the gray code into its equivalent binary value. So assuming our gray code is the same as we had in the earlier example, 0 1 0 1 0 1. So we write the gray code bits 0 1 0 1 0 1, and we convert this into its equivalent binary. So as we saw in the previous example, the MSB of the gray code is copied and it becomes the MSB of the binary code. So this bit has been copied. Then after that, we take the newly generated bit of the binary and XOR it with the next bit of the gray code. So 0 XOR with 1 will give us 1. This one XOR with 0 gives us this one. So at every step you can see that the new bit that is produced in the binary, it is XORed with the next bit of the gray code. So 1 XOR 1. 1 XOR 1 is 0. There we have it from our XOR truth table. 1 XOR 1 is 0. So that we generate the 0. Again 0 XOR with 0. So again we have from the truth table 0 XOR with 0 is 0, and 0 XOR with 1 gives us 1. So we now know that this gray code is equivalent to 0 1 1 0 0 1. So this number that we have is the equivalent binary value, and we know now from our previous session that we can convert this into the equivalent decimal value, and that becomes 25. So this is 0 1 1 0 0 1 of the decimal. We attach a weight to each bit. So this bit has a weight of 1. Since the bit here is 0, its corresponding weight is 2, which is ignored. So let us just write the weights below each. So 1, this will have the weight 2, this will have the weight 4, this has the weight equivalent weight 8, this bit has the equivalent weight 16, and this bit has the equivalent weight 32. Now wherever we have the bit positions as 0, we ignore the weights, and then we are left with 16 plus we have a 1 bit here, so plus 8 and plus 1, so that becomes 25, and therefore we say that this equivalent value is 25, and therefore 0 1 0 1 0 1 of the gray code is equivalent to 25 of decimal. This is how we convert a gray code into its decimal value.